In this video I'm going to look at the regions property page and how we create a background on data such as these. This is a very basic spectrum, and when I create a background I might perform operations such as I've just done, where I've moved the start and end parameters for this background, so I have a region over which I can integrate the signal above background and then therefore get an estimate for the amount of solver 2s. But there are other parameters such as the background shape, which is determined here by the BG type parameter, and it's a Shirley background. So this is being calculated directly from the data, and we see the characteristic step of the Shirley background that would be a consequence of this particular shape. There's also an average width, and this represents the number of data points either end that are integrated so that the background and the data tie at these points. So let me just adjust that and make that say 5. And you can see the interval over which the data is integrated so that you get an intensity for the background at the start and the end. And now it's quite clear that we could just integrate a signal above the background and estimate the area of this peak based on the parameters that we've got here. However, this peak itself is very Lorentzian, and when I choose a background and I choose a different position for the start and end, I get a different shape for this peak. And this is important when we do peak fitting, because we create a peak model and then we try to model each individual photoemission peak by a line shape. And if we influence the shape that we need to use in the model by our choice of the background, then we may end up with some anomalies in how we calculate the peak model, the meaning of the peak model, and the relative intensity of the peak model with respect to other photoemission peaks. So if this is a more Lorentzian line shape, then I would prefer to have a wider energy interval, and then when I create a component I would like to use a line shape that is more Lorentzian. So I'm using a Voigt line shape and I say fit. Now one of the things that we can see is that the wings of the Lorentzian are such that the component does not fit the data because of the background that we've chosen. So perhaps we ought to offset this background to allow these wings to fit the data, and that's exactly what you can do with the start and end offsets. If I go to the components property page, I'm then able to adjust the offset that is defined here, and now I have a shape that fits the data. And perhaps another tweak, and you can see that I would have to iterate towards the best fit. So I've ended up with a very good fit for these data, but it has required me to manually interact with this start and end offset in order to achieve a fit based on the line shape that I chose. And who's to say that this is the correct line shape? Well, that deserves another video to explain how we might go about choosing the best line shape for these data. But in this case we'll just assume that this is the best line shape. I have to manually adjust the offsets at the start and end because I've chosen a specific start and end and a given intensity that my background starts at with respect to the data. So this is all adjustments that are required to try and use a line shape that is sympathetic to data.